Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about dissolved oxygens. So what is dissolved oxygen? My friend, dissolved oxygen is the amount of gaseous oxygen, the oxygen in gaseous form, present in the water in its dissolved state. You understand? Dissolved oxygen is the amount of oxygen present in the water in its dissolved state. Dissolved oxygen is the most important indicator of the health of water body and its capacity to support a balanced aquatic ecosystem of plants and animals. A higher dissolved oxygen level indicates a better water quality. Very important point. Higher dissolved oxygen level indicates a better water quality. If dissolved oxygen level are too low, some fish and other organisms may not be able to survive. Now, how it is available? Mostly dissolved oxygen in water comes from oxygen in the air. The next important point, it comes from photosynthesis done by aquatic plants. And next important properties, water temperature and the volume of moving water affects dissolved oxygen level. Oxygen dissolves easier in cooler water than warmer water. Now, salinity is also an important factor in determining the amount of oxygen a body of water can hold. Dissolved salt in the water increase the amount of oxygen the water can hold decrease. For lower saline water, it increase. So, dissolved oxygen measurement method. How you will measure dissolved oxygen? This is our task. There are three methods available for measuring dissolved oxygen concentration in water: titration method, colorimetric methods, and optical or electrochemical sensor. So, titration method. The method for dissolved oxygen analysis is known as Winkler method, also known as iodometric methods. So, chemical required for the Winkler methods: manganese sulfate solution MnSO4 4H2O, alkali iodine oxide, concentrated sulfuric acid, a starch solution, standard sodium thiosulfate solution, and standard potassium dichromate solution. Now, what is the procedure? First, take 300 ml of water sample in the bottle. Add 2 ml of manganese sulfate solution and 2 ml of alkali oxide solution to the sample. Mix the solution obtained by inverting the bottle for at least 15 times. Precipitate begin to form and allow it to settle, leaving and clear supernatant liquors above. Shake again. After 2 minutes of settling, remove the stopper and add 3 ml of concentrated sulfuric acid by allowing acid to run from the neck of the bottle. The next important point, apply the stopper and mix again until the dissolution is complete. Now take about 203 ml of solution from the bottle to flask. So, titrate with 0.025 in sodium thiosulfate solution to pale straw color. Then add 1 to 1.2 ml starch solution and continue the titration until blue color disappears, and note down the volume of sodium thiosulfate added which DO value in milligram per liter. Conclusions: how to calculate So the formula to calculate amount of DO will be given as amount of DO, means dissolved oxygen present in water sample, is equal to total volume of sodium thiosulfate required, normality of sodium thiosulfate 1000, and equivalent weight of oxygen by volume of sample. So chemical reaction, you can see here white precipitate formations Mn plus 2H minus, it give MnOH2. Brown precipitate formation MnOH2 O2 with 2 water molecules, you will get the MnOH thrice. After adding acid, you will get the iodine, and then titrations of iodine with thiosulfide H2O32 minus, thiosulfate will form S4O62 minus. So another important methods, colorimetric methods. There are two variations of dissolved oxygen analysis by colorimetric methods. There are known as a Indigo Karmin method and the Rotazine D method. Both variations are colorimetric reagents that react and change color when reacted with oxygen in water. These interactions are based on the oxidation of the reagent, and the extent of the color change is proportional to the dissolved oxygen concentration. A spectrophotometer, colorimeter, or simple comparator is used for measuring dissolved oxygen. Now, Indigo Karmin method. What is this method? The Indigo Karmin method is used for measuring dissolved oxygen. Dissolved oxygen, it is clear to you. Concentration between 0.2 to 150 ppm, milligram per liter. So this method produces a blue color, the intensity of which is proportional to the dissolved oxygen concentration. Now, this method is not affected by temperature, salinity, or dissolved gases. So, Rotazine D method. What is this method? Rotazine D method is used to determine very low dissolved oxygen concentration, up to parts per billion. Rotazine D reagent react with dissolved oxygen to form a deep rose colored solution. And this colorimetric method is not affected by salinity or dissolved gases present in the water. Simple. You know, my friend, in addition, sample color and turbidity can affect the accuracy of the reading. This method is time dependent and analysis must be made within 30 seconds of mixing of the reagents. So, optical sensor. You know, my friend, optical dissolved oxygen sensor measure the interaction between oxygen and certain luminescent dyes. When exposed to blue light, these dyes become excited, electrons gaining energy, and emit light as the electron return to their normal energy state. When dissolved oxygen is present and the returning wavelength are limits are altered due to oxygen molecules interaction with the dye. The measured effect is inversely proportional to the partial pressure of oxygen. So, my friend, as oxygen crosses the membrane, it interacts with the dye, limiting the intensity of the luminescence. The intensity of the return luminescence is measured by photodetectors and used to calculate the dissolved oxygen concentration. So, significance of dissolved oxygen in water. The level of oxygen is a much more important measure of water quality. You know, my friends, dissolved oxygen is absolutely essential for the survival of all aquatic organisms, not only fish, but also invertebrates such as crab, clams, and zooplanktons. And most important things for the significance of dissolved oxygen is oxygen affects a vast number of other water indicators, not only biodissolved, biochemical, but also like the odor, clarity, and taste. So as dissolved oxygen level in water drop below 50 milligram per liter, aquatic life is put under stress. The lower the concentration of oxygen, the greater the stress. So oxygen level that remains below 1 to 2 milligrams per liter for a few hours can result in large fish kill. Total dissolved gas concentration in water should not exceed 110% concentration. Above this level can be harmful to aquatic life. Fish in water containing excessive dissolved gases may suffer from gas bubble disease. Now, however, this is very rare occurrence. So external bubbles can also occur and seen on fins, on skin and other tissue. A commonly water supply a high dew level in good because it makes drinking water taste better. However, high DO level, dissolved level, speed up corrosions in water pipes. For these reasons, industry uses water with the least possible amount of dissolved oxygen. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.